Right, good morning, everyone, and welcome to this theoretical sessions about software architecture. What I'm going to talk to you guys about this morning is a little bit about like, what is the reason behind how we structure our applications the way we do right now, and the internals of how um, the applications that you're building actually go about responding to their users. Okay, so is one of the ways of sort of like structuring web application, and like you'll find that most web application nowadays are actually um, built around this way of designing things, right? What it allows us to, what it is essentially is just a way to like separate the functionality of an application into multiple layers. Each layers being a segment with a tier that can be located on a physical separate computer. Okay, so you can have basically parts of your application running on separate computers and all performing performing towards the same goal. This architecture is characterized by the functionality by the functional decomposition of applications, service components, and their distributed deployment, providing us with a much improved scalability, availability, and manageability of the resource utilization of the application. Okay, I know this all sounds like lots of big words and stuff, but let's kind of dive into the details of it. Now, I mentioned like the name suggests, we have three tiers here on this architecture, and the structure is basically as follows. So we have these three tiers. The first tier that we of this architecture is the presentation layer. Then you have a logic layer and a data layer. Now, this first layer here is the topmost level of the application. This is what the user basically sees when they interact with your application, right? This is the first step they go through when they have to communicate with your applications. Okay, so whenever they make a request, the request starts from the UI and then goes back to a server for processing, and then the server will then return back the result to this presentation layer. Okay, so this is what presentation tier is all about. The logic tier controls the application's functionality by performing, processing. So when you have to do things like calculate the total of an order, for instance, that's the logic part of your application that takes care of that. Okay, like all the critical business, you know, logic or problems are solved in the logic tier. Okay. And then the last layer of this architecture is the data tier. This is where the information is stored and retrieved. Okay, so this tier is responsible for um, separating, you know, the application server or the business logic from what the user sees. Okay, so it gives the data its own tiers, which allows for a much improved scalability. And you will see when we get to the next stage now, because of this, it means like you can have your data stored on a separate computer and have application communicating to the same data stored on a different computer. Okay, and I'm not going to dive too much into the details of that now because it probably won't make sense to you. But once you build more application, you will start to understand what are the real benefit of splitting all these layers the way we do it when building web applications. Okay, so this layer here is basically your database. This is where your database sits on this layers. Now let's look at this diagram here um, to kind of like response at the cycle of at the request response cycle when a user needs something from your application. This kind of like looks similar to what I presented to you guys last week when we were talking about static website, but then we have some more complex things going on here. Okay. Now this here is what happens when we deal with dynamic applications versus compared to static application. So when a user, for instance, comes to your application, right? Let's say you're building a social media platform and you need people to register for, to register their profile on your platform. What will happen is that the entry point for them is going to be a web browser. So they're going to get to a web browser, and then they're going to type in an address in the web browser in this bar here, and they're going to submit it. Okay, so when they submit this, what happens is that the request goes onto a server. So the server is basically where your application is sitting, where your application is running at the time. And so the user sends a request saying, hey, can I please get a form to create a new user? That request goes into the server, and then the server will process the request. Okay, and then it's going to say, hey, there is the form to create your user. Then we move from the server. The server sends back the page, and this is what the user then sees, right? So when he gets the form, he or she gets the form, he then they have to fill up the information that is required by the application, and they have to push the submit button. When they push this button, what they're saying is that, okay, um, a new user called John, for instance. This very same request here goes back to the server again, right? And then once the server processes that request, it creates the user, and then sends a response to John and say, okay, look, we've created your user, and we're done, right? Just like this is what happens when the user requests a certain resource from a web application. Okay. Now this diagram here shows you, like, at an abstract level, what really happens. But if we dive into the nitty gritty of the technicality of all that, um, when when he says, "Can I have a form to create a new user?" What he's actually saying, he's making a request, and we're going to see that later on. We're making a GET request. Okay, so we're making an HTTP request to the server, because the way the client here being your browser talks with the server, okay, is by means of HTTP request. So the protocol that allows for communication between those two computers is essentially this HTTP protocol here, right? And the HTTP protocol, just like any means of communication, has certain rules that you need to follow in order to send a message to the server, and the server will use the same protocol to respond back to the client who made the request. Okay. In this context, when we want to sort of like get the page that gives us the form that we need to fill up, we make a GET request to this URL here, this route here. Okay, the route here is user/new. We send this request to the server. The server will be able to receive that request and dispatch it to the application engine, right? So this is the application engine is responsible for, like, processing all the requests, do all the calculation if need be, and then return back a response to the user. And the response that gets sent back is also an HTTP transaction with a status code saying, okay, we were able to do this. Now, there's a number of verbs that you need to know about when it comes to sending requests, and we will learn about them. You've actually started using them already this week with Sinatra, but we'll talk more about them next week when we go deep into routes. Okay, so this is what really happens behind the scene. But then we can go a little bit further with this diagram and kind of unfold all the stacks, all the language, the libraries that goes in between every response. I mean, every request that we send to a server. Okay. Right. On the front end side, what you will often deal with are going to be things like, jQuery to do interaction on the browser, AngularJS or React or whatever framework that we need to sort of like manipulate information on the front end here. Okay. Now, the languages that are mainly used on the front end are going to be HTML, CSS, and JavaScript, which is stuff that you've been working on already. Now, when it comes to communicating between the browser and the server, there are a number of protocols that are in place to allow for that communication. At the top level, we have things like, so first we start with RESTful. If you're working with REST is just a way to define how we want to send resources or information from a server to a web client. Okay, we're going to talk about REST in more details when we start building what we call web APIs in week 7, right? But this is more like a framework to define a set of rules of how we want to structure the data that we want to send back and forth between the server. Okay, when we go level down, we have the HTTP protocol, which sits on top of the TCP/IP stack. So this goes down to like bare level. So this is what network technicians have to deal with. Basically, you don't have to worry about how this works. All the networking engineers are the ones that are responsible for dealing with this, right? Now, when we get to your web server, okay, on the web server is basically an application that is responsible for receiving these HTTP requests that the browser sends, and it knows how to translate those requests to your application engine. Okay, the application engine will be responsible for processing all that information and returning a page back to the user. Okay, examples of web servers, the most common one that you will hear about are Apache or Nginx, but you also have IIS, which is Microsoft Internet Service, I think, and other servers are Thin, WebRick, Puma, Unicode. Now, if you were paying attention to the output of your terminal this week when you were starting the Sinatra application, you probably saw this name somewhere. If you haven't, I'm going to show you that in just a second. Okay, and the languages that are built, that are sort of like used to build these applications are C or C++. Okay, and then you have the application engine, which is where you guys will spend most of your time. So your job as a web developer will be spent mostly building things at this level or at this layer here. Okay. And you see this week we started introducing you guys to Sinatra, which is a framework that allows us to build, all the element that the application need in order to process and respond to requests. Okay, we started with Sinatra. You will be introduced to a different framework next week called Rails, and you have Node.js for JavaScript. If you want to build web server application server-side application using JavaScript, you can use Node.js. J2EE is Java, and .NET is C# mostly. Okay, so these are the languages that correspond to these frameworks. And what the application engine is responsible for is essentially when the web server gets this request here to, say, return the form to create a new user, what the application engine does is that, first of all, it knows we should define at our application engine layer the route that the user might need in order to request such a form. If this thing is not defined in our application engine, what will happen is that the web server is going to return a response back to the client saying that, hey, I couldn't find the page you were looking for. Maybe try something else. Okay. But if it does find that, if you as a developer defined a route that matched this request here, what will usually happen is that in the case of Sinatra, for instance, you use the verb get to define the route that you want to serve, and you're going to usually have some form of processing here before you actually respond with with a web page. Now, the response that you build here is going to be a combination of maybe some templating engine for your front end. So the templating engine is going to sort of like take pieces of HTML code combined with some Ruby in the case of Sinatra and ERB, and then return that information back to the user in the form of an HTML page, right? So all that mix and matching happens at the application engine layer, right? And then ultimately, the last layer for this is the database, right? And the database, this is where you get things like Postgres, MongoDB, and so on, to sort of like persist the information that you want to store. Okay. Now, one of the biggest benefit of having such a modular architecture is the fact that you can potentially run every single part of this architecture on separate servers. Just to clarify, I think a server is just a computer that runs some, specific software in order to respond to the request that the user sends from the browsers. Okay, so it's just another computer. Your laptop can play the role of a web server as long as you have the right application installed on them. Okay, so you can run your web server on a completely different computer. You run your application engine on a different computer, and your database sits on another computer. What this allows us to do, when we talk about the advantage of scalability, for instance, it means that if you take the example of a company like Facebook, for instance, they probably have thousands of servers for just the application engine, right? Because when these requests comes to the web server is supposed to sort of like send them to the application engine for processing. You can imagine that if we have millions of people trying to do different things on the same application at the same time, it's gonna put some pressure on the server itself, right? And things become slow, and like, the response are not as quick as we would expect. Now, because we build things on this architecture, we can have multiple servers running this portion of the stack, okay, but then all through some you know through some ways of, there are some ways, some mechanism by which you can then link all these applications together to talk to the same database. Same thing for the database. You can have multiple copies of your database on various servers that are talking to the same application at the same time, right? And because you have the more servers you put in place to serve your application, the better you have a much better performance in order to respond to all the requests that come through to your application, right? So this is one of the big advantage of splitting things the way we do at the moment. It also allows for flexibility because I can decide to sort of like scale every tier of the application independently of others. If at some point I realize that I have more requests coming through to my application, I need to bump up the number of the processing power of the application's engine. I can just spin up multiple to run the same application and just connect them to the same database. If at some point I realize that I don't need that much power, I can just decrease the number of servers running this this layer of the application, right? Allows for flexibilities. One of the other benefit of this is availability, right? Because of the modular architecture, you know, the system can easily scale and it increase the availability of the application overall. Okay. Now, all of this is fine, but like in practical term, how does this? Are you guys, after seeing this, do you guys think you can, from the perspective of Sinatra, identify the main components of how we are building this? Yes, no, not
Can you
not really.
kind of like I didn't really understand the question. You kind of disappeared for a second in the middle of it, for me at least.
Yeah, for me too.
What I was asking is that when you look at this whole diagram here, and you think about what you've been doing this week, does this kind of like make sense to you? Do you have a bit of a bigger picture of what's going on in the application that you're building at the moment, or it's all blurry, really?
I think it explains quite nicely. Of course, maybe I don't get the full picture yet, but I think it gets give me a better idea of the whole picture at least.
Right. Because one of the reason why it is important for you to kind of understand this is as you build your application, for instance, and things start to go wrong, because you have this mental picture of how the whole request cycle goes, you should be able to pinpoint, okay, if I'm getting this error, it's probably because of the web server not being able to respond to me, or maybe the application engine failed to do something, or maybe I can't connect to my database, etc., right? It basically allows you to be a little bit better at debugging problems that occurs with your application. I'm just going to show you a little bit. Let me see if I can pull down the code from this week. October 17. So we go to Slowfood Sinatra. Okay, so I'm just going to pop this open. I think just to summarize a little bit on all the stuff that I just mentioned now. You can see that one of the most important thing when it comes to interacting with your web application is that you first of all need to have a route to serve every resources that you need in your application. So this is like the entry point to your application. In order for a user to see something on your page, they need a route to get there. Okay. And that's why most of the time, at least up until now, in order for you to serve a specific page, you had to define these route here. Okay, so if you don't have this, then your server will not know how to respond to a request that the user has asked for. Okay, so because when I look at this application at this current state here, the only routes that this application knows of is the root path. Okay, so root path. It's the login route, the sign up, users, and register. This is the only thing this application is able to serve at the moment. If I try to access a route, say, hello, the server will likely respond to me and say, hey, whatever you asked me for, I don't know about it. Okay, because it is not defined here. All right. Now, when you have your route, and the way Sinatra is structured here is that, first of all, you need to specify what verb is responsible for processing the information on that route. In this case, most of the time when you want to sort of like view some information from the application and without sending something in, you'll do so using a get verb. The main, hold on a second. So I mentioned earlier on that some of the HTTP verb that we have to make request are, so we have get. This is the only example I pointed so far, but you also have a post. Okay, so post, when it comes to sending requests, the post will usually be used to create resources onto the server. Okay, so here you are sending data to the server to create new resource. Here you just like the verb says, you get some data from the server. Okay. Then you have delete, which is used to obviously delete data on the server. And then you have put or patch, which will be used to update a resource on the server. Okay. So when it comes to Sinatra, the way you will define them using the same structure, where you select the verb that you want to make use of, followed by a route that matches what you want to do. And inside of this block here, you will basically have the logic that needs to happen when we receive such a request. Okay, in this case, for instance, the root path is set to get all the products that we have on our database and then render a view called welcome. Okay, so this is what this thing is supposed to do. When you submit a post, whenever you submit a post request to your web application, you will usually have this object here, this params hash, which will contain all the information that was sent from the client to the server. So if we look, for instance, at this form here, we have a name, an email, phone, and address. So all the values that are submitted as part of these form here will be part of the params hash. Okay, and so this is how you then get access to the information that is coming from the client. Okay, now you may be wondering, where does this web server comes from? We know that at this stage here we have our Sinatra application, but where does this web server come from? Whenever you do what is the shotgun? I think, or are you guys using Rackup? Bundle, of course. You guys are using Shotgun. Okay, Shotgun, Rackup. Pretty much. I'm gonna use Rackup here, but I could also use Shotgun. I need to create. All right, an initialize constant get. That's because I. Okay. Start this up. Right. So whenever you start Rackup here, what you're essentially doing is starting up a web server. And if you remember that slide, we saw that WebBrick was one web server that you can make use of. Okay, so when you start this command, whether it's Rackup or Shotgun, what Rackup does is essentially starting a web server that is going to serve the application in order for it to be accessible via browser. And what it does is that it tells you, if you want to access this application, you need to go onto your browser. Because we're running this locally, you would need to put in localhost and the port number on which this web server is currently running. Okay. When it comes to, so if I want to access this, I would then say localhost 9292, and then it accesses. At this stage, it doesn't work, but like I can check on the logs here, what was the problem with, what happened, what went wrong with this request for it not be fulfilled. Okay. We will talk about some error codes at a later stage, but essentially a 500 range usually mean there was some internal some errors on the server. But let's not get into that now. I'm just gonna. So this local host here basically translate to an IP address 001 and a port number. Now, whenever you go to a website, let's say for instance, craftacademy.co, you need to enter the string value, right? But then what this value ends up being to the computer is a series of number. Okay, so this text here gets translated to a series of number that is exactly similar to this one, where we're gonna have the IP address of the server where this application that we're trying to access is currently running. Okay, and the tier that is the services that are responsible for translating these domain name into is the DNS. Okay, so the DNS will it's like a huge repository of that a huge repository that sort of like match names, domain names with servers' IP addresses. Okay, and so when I go to this one, what's happening is that this request is going to go to look up for the IP address that match that name, finds the server based on the IP address that is defined there, and the server in question is going to process my request and then return to me an HTML page like you see here. So Rackup starts a server. We have a similar server running for this application on a remote server. Okay. You've seen where we define routes in our applications, and you've also, okay, we've talked about the application engine, and then the database, of course, comes in. So if I look at the Sinatra setup that we have here in our configuration file, we need to tell it where to, how to connect to the database management system that we are using for this application. In our case, because we're using Postgres, we need to make sure that Postgres is installed locally on our computer. But you could also run, I can application run Postgres on, say, Alfred's computer, right? But I need to be able to, I need a little bit more networking knowledge to know how to connect my computer to Alfred's computer so that this application that is running on my computer can connect to his database. Okay. So this is like kind of roughly all the pieces that are in place when you have to build an application. Any questions? Are you guys still with me? Oh, I've been talking to myself.
Yeah,
no,
we are here.
We hear you loud and clear.
I guess you're just processing all of this.
Yeah, definitely. Yes. Questions will arise.
Right. So, yeah, whenever you are dealing with this, especially when you're doing the AUT cycle, like try to keep this flow in mind, right? In order for you to get something, you need to make a request. To make that request, you need a route, right? That route needs to be able to go to a web server. On the web server, if we need some information from the database, we need to be able to connect to the database, get the information, bring it back to the application engine. If we need to render view back to the user, we need to be able to find the template for that specific view, and then combine all the information together to the user. Always keep that flow in mind. It all starts with the route. And so
yeah, no, I start to see why you are pushing us to understand better and better params, because basically they set the routes. So I understand why it's so important to get them, because otherwise it's a basic concept for us to, especially for the step related to the application engine.
Yeah.
So yeah, I mean, yeah.
So I think the other takeaway here is that whenever you are creating a resource on the server using a post request, you should always expect to have this params object available for you. So this is how you get those, that information from the client onto your application engine. Okay. In most cases, when you do a get, you will also, I think you should also have the params hash, but it won't have any useful information for you to use here. But I think you can have that as well. Actually, you can, because if I want to say get information about a specific user, what I would probably have to define is a route called users, and then this thing will need to get as an argument the ID of the user that we want. Now with this ID, I can ask the database for the user that match this ID, right? So I extract the ID from, so because I define my route like this, it will automatically create a field on my params hash that will contain the value of the ID of the person that I'm looking for, right? And then I can pass that to the active record method that will allow me to find the user matching that ID. Okay, and then I store that here. Once I have it here, I can then pass it onto my to a view to sort of like render the information about this user. So you always get the params object available to you. Right.
Yeah, I actually understood params because I was watching a video on YouTube, and then I checked their URL, and like there is really like params show that to you anytime you are like watching a video and check. Yeah, so I mean it's basically out there, especially on YouTube. Of course, in everything, but I notice it in YouTube more.
Yeah. Right. I can take another question if there are any. But otherwise, this is my talk.
Are you ready? I have a question.
Yeah, sure.
Yeah. So okay, wait. So like with like the whole get and post thing, like the main difference. Echo. Yeah, but the main difference between the two is that a post makes a new resource in the database, right? And then
correct.
Get is just like when that user makes that certain request.
Correct.
Okay.
That's correct. So you want to use post when you need to create a resource on the database, and you make use of get to basically read information from the database or from your system.
Right. Okay.
One thing that I want to point out as well is that get is not only for reading stuff from the database. Just see it as getting some information from the server back to the client. Okay, we're not sending anything to the server. We're not creating any resources. We just want to get something. It could be just rendering a static page, for instance. Okay. Most of the time, whenever you're visiting a website, for instance, that when you type in the URL of that website in your browser, what you're doing most of the time is you submitting a GET request to that server to get that page. Okay, and I can show you that quickly here. See, now I'm going to show you some nerdy stuff. Now, websites are not just going to be what they used to be. If I go to this network page here, right, let's see. So if I do Academy that, you see what happens? You see what was submitted? We submitted a GET request to have the root path of that application, okay? And what we get as a response, we can see the content type here is an HTML page. So the server received the request, okay? And then it replies with some HTML. And this is why we see this thing here. All right. Now for every other images that we're using on this page, for instance, we will have a subsequent HTTP request that gets submitted to a server to get that. Let me see if I can push this away. Do we have some images somewhere? Here, for instance, I think this is an image. No, this is a style sheet. So we made a request, another request to get the style sheet for this page. And here I think I have the JavaScript for that page. What else do we have? Fonts. Where's the image? Okay.
Why did you store the style sheet and Java? I mean, that's the database, right?
No. So remember when you create your page, if you look at the source for your page, you will see that you include the link to your style sheet here, right? Here.
Yeah. Now
here's the link to the style sheet, right? So this is going to issue another request to the server to download this file onto the browser, because we need this file in order to have our website looking good like this.
It's like the one for the Bootstrap. Yeah. Now I understand what is going on. I was like,
so every single time we need something on the page, it's going to issue a request to the server. Okay. Now, if we had a form on this page and we were filling that form, if I had submitted it, you would have seen in the network section here, you would have seen a post request being submitted to the server. Okay.
Yeah.
Everything on the web, this is how the web communicates. Like every page on the internet will communicate the same way. If I need something, I submit a request to, there's always going to be a server involved. Okay. Submit a request to the server. If the server has it, it will return the file to me. If it doesn't, it will throw an error. Okay. And your job as a developer will be to, well, surely by the end of week 6, you will understand what this status code means. You know, when you see these numbers, you will know that 200, for instance, meet the request. We got a response back. It was a success. 400, you know, something went wrong. We didn't have access to the resource that we were looking for, or maybe we couldn't find it. 500, something wrong happened on the server. 300, you know, it was redirected, and so on and so forth. So you will understand what these numbers mean. You will understand how to make use of these HTTP verbs, when to make use of them, to get or send information back between servers, and so on. Okay. This is what you should know as a developer. Okay.
Yeah. Now, last thing, it's not the question, just to clarify and to build on what Scott asked you. So you already explained pretty clear, just to be, you know, I don't want to ask this again. So put patch is to basically edit an information database that is already there.
Right.
And post instead is like creating something completely new. So if like I create a new user, I'm posting basically. I mean, I'm using post. Okay, perfect. Just to be clear.
That's correct. So whenever you're working on a feature, for instance, if that feature requires you to create something on the server, you will usually need to, like the way it's done is that you will need to routes define, at least 2 routes defined for that. The first route will be, so let's say new user. So this is going to be the first the first route you will have to define. All you need to do here is return to the user turn a form, okay, for the user to fill up, okay. Then the second part to creating a user would be a post request to the user, as an example.
Okay.
Because in order for the user to submit the information, they need to have a form, right? And in order for you to serve them the form, they need to send a GET request to receive that form. Once they have the form, now in your form, when you're defining forms, you usually have, now this is HTML that I'm going to write here. You will usually have an action attribute that will need to take a route. Here you will need to specify a route to create the resource. Okay, so this is usually where, and then the method is going to be right. So here, in order for us to submit this form, we would have to say /users, and then when we submit this form, when we push the submit button of this form, it's going to make a request to this route now to create a user with information from the form. Okay, and when I say with the information from the form, you guys understand now that you will get this from this. Right? So this is what it takes in most cases to create a resource on the server. The form, and this is how you render that form. Secondly, you need a route to process the information that is submitted from the form. Okay.
Thanks.
Good. Any other questions before we part ways?
See you next time. Bye.
Okay, guys, you have a good day. I'll see you
Thank you.
later.
Bye-bye.
Thanks.
Thank you.
Thank you. Bye.